Let's talk about trigonometry. You ever wonder why we even bother with it? What if I told you the real story isn't about confusing formulas, but about an epic 2,000-year quest to understand the entire universe? Trigonometry. Be honest, just hearing that word probably gives you flashbacks to high school math, right? Just this sea of sines, cosines, all these formulas that seem to just appear out of thin air.
I mean, come on. How many of us have felt exactly like this? It's a totally fair question. When something feels so abstract, so disconnected from anything real, you have to wonder. But what if that's just the wrong way to look at it?
Because what if trigonometry isn't just some boring chapter in a textbook? What if it's this incredible 2,000-year-old story of human achievement? A story that starts way, way back in the ancient world. And this is what's so cool. It wasn't invented by just one person in one place. No way. Just look at this journey. It kicks off with the ancient Greeks and Babylonians. Then the intellectual torch gets passed all the way to India. That's where mathematicians like Aryabhata cooked up the very first sine tables. I mean, think about that. This knowledge was built up piece by piece and shared across totally different civilizations. It's a truly global human story. So let's totally reframe this. Trigonometry wasn't invented to torture students, okay? It was created out of this deep, profound human need, a need to measure the heavens, to understand the stars, and figure out our place in the whole cosmos. So how did they even begin to do that? Well, they had to learn to speak the language of circles. And it turns out there are kind of two main dialects we can use, two completely different ways to talk about the exact same thing. Okay, so on one hand, you've got degrees. Super simple. Just picture a pizza, right? Cut it into 360 perfect equal slices. Each one of those little slices is 1 degree. Easy, intuitive. But then you have radians, and this is where things get really interesting. Instead of some random number like 360, radians measure a circle using its own radius. And because it's based on the circle's actual properties, it becomes this natural language for describing everything from waves and rotations to a huge chunk of physics. And here's the idea in a nutshell. A radian, it's just the angle you get when you take the radius of a circle, that line from the center to the edge, and you lay that exact same length along the curve of the circle. See that angle it makes at the center? Boom! That's 1 radian. It's an idea that's born from the circle itself. Okay, so because trig is this natural, elegant language, it lets us find these amazing patterns. Patterns where something that looks impossibly complicated suddenly just collapses into something beautifully simple. You gotta see this. All right, consider this problem. Just take a look at it. Cosine of pi over 7 plus cosine of 2 pi over 7, all the way up. I mean, wow. Your first instinct is probably that you need a scientific calculator and like a whole afternoon to figure this out, right? But what if I told you we don't have to calculate anything at all? Seriously. What if we just look for a pattern? Let's just try pairing them up. We'll take the first term and pair it with the very last one. Then the second term with the second to last. And finally, the two left in the middle get paired together. And right here, this is the magic trick. This is the key insight that just blows the whole thing wide open. There's this beautiful, simple rule in trigonometry. It says that if you have two angles that add up to pi, which is just 180 degrees, a perfect half circle, their cosines are equal but opposite. So when you add them together, they completely cancel each other out. They just become 0. So let's look at our pairs again. The first pair cancels out, 0. The next pair, same thing, 0. And the middle pair, you guessed it, 0. So the answer to that ridiculously complicated-looking equation is just a big fat 0. All of that complexity, poof, it vanishes. That is the elegance of trigonometry. But look, this kind of elegance isn't just for solving clever math puzzles. Not at all. It's actually the foundation of our entire modern world. Because as it turns out, trigonometry is the mother of calculus. And that is not an exaggeration. Think about it. Calculus is the math that describes change, any kind of change, the speed of a rocket, the growth of a population, the ups and downs of the stock market, all of it. And it is completely built on the language of trigonometry. Without trig, forget about modern physics or engineering. It just wouldn't exist. You'd have no vector theory, which means no GPS to get you around, no coordinate geometry, so say goodbye to video games, and no signal processing. And that means no Wi-Fi, no streaming music, nothing. It's literally the invisible mathematical backbone of the world we live in. So that leaves us with one final thought, right? We started this whole conversation seeing trigonometry as just some hard subject in school. But now we've seen its hidden story. It's this fundamental language. So the real question I want to leave you with is this. Could we even begin to describe our universe without it?